Let's look at a quick example here to see how we can use the equations from our previous video with our op-amp circuit. So here what we want to do is we want to determine the expected input resistance seen by some input voltage for a non-inverting op-amp circuit. And so what we want to see then is we're trying to determine this input resistance that our input voltage Vi is seeing. So we can call this R sub IF to be consistent with our previous video. And so we notice we have R2 and R1 values given in the circuit, and then the green values here are specifications for the amplifier itself, this actual op-amp sort of in the middle of the circuit. So we see that it has an input resistance of 50 k ohms and an open loop gain of 10 to the fourth. So what we need to do is we're going to use our ideal form where we said our R sub IF is equal to our Ri times 1 plus AV times beta V. And so this is for our voltage amplifier, so this is our ideal equation for our voltage amplifier, our series shunt configuration. And so we actually already know the Ri value, we already know the AV value, both of those are given, and we just need to figure out this beta sub V value. So what we saw in the previous video is that this beta sub V value is dependent on these resistors, R1 and R2, that are external to the op-amp. So we have 1 divided by 1 plus R2 over R1. So plugging in our values, we have this as 1 plus our 90K divided by 10K, which is equal to 0.10. All we need to do now is plug it into our equation above, and we can find our R sub IF is equal to, our I was 50K times 1 plus our open loop gain was 10 to the fourth, and our beta sub V we found is 0.10. And then we just plug in and we get our input resistance seen by our voltage source is 50.05 mega ohms. And so keep in mind this is desirable for an input to a voltage amplifier, because if we have some input voltage that we're trying to amplify Vi, oftentimes it's going to have some associated series resistance. And what we're doing then is we're connecting this to our amplifier. So if I represent our amplifier in green, our amplifier can be represented by some input resistance R sub IF. So this would be our sort of actual input resistance V sub I prime into the amplifier. And of course we want this V sub I prime to be as close as possible to V sub I. So for some non-zero R sub S, the best we can do is make this value really large. And as we see here, having this feedback network has taken our input resistance from a relatively small input resistance value of 50K to a much larger value of 50 mega ohms.